Okay, so I want to show you one example that kind of has everything that you could throw in it as far as transformations of the sine or cosine function. So we're going to graph y equals 4 sine of the quantity 2x minus 2 pi thirds. So this one has a change in amplitude, a change of period, and a change in the phase shift. The only thing it doesn't have is a vertical shift, but that's easy. You just slide it up or down based on the value of d. You can look at that example in the notes. So the way that we're going to start is we always need to determine the values of A, B, C, and D, and it's always helpful to work through them alphabetically. Because they kind of depend on each other. So I always just remember to work through them in that order. Now for sine, remember that it's going to be y equals a times the sine of bx minus c plus d. Okay, so for this function, a is equal to 4, which means that the amplitude is equal to 4. Remember, amplitude is the absolute value of A. So if my A had been negative 4, the amplitude would still be positive 4. B, in this case, is 2. B helps us determine the period of the function, how long it takes to get through one whole cycle. So to determine the period, we use 2 pi over B. So 2 pi over 2, that means the period here is pi. So this one is going to complete a cycle of up, down, up in half the distance of the regular function. C, remember, is another one of these deals where you have a negative in front, so it's really the opposite. So since I see minus 2 pi thirds, that means that the value of the letter C is positive 2 pi thirds. Now the phase shift is equal to C over B. Notice that in both of these cases, the value of b was the denominator of the fraction, and so I like to remember that b for the bottom. B always goes on the bottom of the fraction. Anytime that you use b, it's always going to be in the denominator on the bottom, okay? So c is 2 pi thirds, and then we need to divide that by b, which is 2. Well, half of 2 pi thirds is going to be 1 pi third, so the phase shift, positive pi thirds, is going to be moving to the right pi thirds units. Okay, now the phase shift changes the starting value of your table. So when you looked at the parent functions, we were looking at starting at 0 and a period from 0 to 2 pi. So we divided it up in terms of pi halves. It's going to be a little bit different here with the transformations. So the first thing that we know when we set up this table is our x's are going to start at pi thirds because that is the phase shift. Now I have to figure out what I am supposed to count by in the table, and you're always going to count by the quarter period. So 1/4 of the period would be pi fourths. That means that's what we need to count by in the table. So the phase shift is your starting point. I remember PS for phase shift, PS for place to start, point to start, however you want to think about that. And then the quarter period is what you count by. So we're going to plus pi fourths over and over again until we get our 5 key points. So in order to do that, we may want to switch to a common denominator. The common denominator for thirds and fourths is going to be pi twelfths. So pi thirds is equal to 4 pi twelfths, and pi fourths is going to be equal to 3 pi twelfths. Oh, there goes the bell. Hold on. So using that common denominator, we can go ahead and count then. So 4 pi twelfths plus 3 pi twelfths is going to take us to 7 pi twelfths. And then plus another 3 is going to be 10 pi twelfths. Plus another 3 is going to be 13 pi twelfths. And plus another 3 is going to be 16 pi twelfths. And that's where I'm going to stop. I know that that's where I'm going to stop because I have 5 points. That's what we always want, is our 5. Anytime we talk about the 5 key points, that is what we want. Now, some of these we're going to be able to simplify. 7 pi 12ths, not so much. 10 pi 12ths is the same as 5 pi 6ths. 13 pi 12ths does not simplify, but 16 pi 12ths is, what is that, 3 pi halves? Nope. 4 pi thirds. Jeez, sorry. Divide them both by 4. 4 pi thirds. Okay. So we have used the period, we have used the phase shift in this point. So now we are going to start with the standard y values for sine. So sine always starts on 0, so the pattern goes 0, 1, 0, -1, 0. That is always the pattern for sine. The only thing that's different about cosine is this pattern starts on 1 instead of on 0. So the last thing then that we need to take into account is the amplitude. The amplitude is going to magnify my y values, so I'm going to take all my y values and multiply them by a, which is 4. So 0 times 4 is 4, 1 times 4 is, just kidding, 0 times 4 is 0. 1 times 4 is 4, then we get a 0 again, and then a -4, and then a 0 again. If we had a vertical shift, if there was like +2 at the end, if we had a value for D, then we would need to go through now and add 2 to each of those y values to get the final look of our curve. But we don't, so we're all set. So when we look at what the sketch of this would look like, oops, sorry about that. When we look at what the sketch of this will look like, we want to draw this out. Let's see here. We've got to go up to 4. So we'll call this 4. We'll call this -4. And then we're going to start counting on pi thirds. I think pi thirds is a good one to count by. So we have 1 pi thirds, 2 pi thirds, 3 pi thirds, which is pi, 4 pi thirds, 5 pi thirds, 6 pi thirds, which is 2 pi. So pi thirds 0 is our first ordered pair. Then 7 pi 12ths is going to be halfway in there. Let's see. Let's put the zeros first. So 5 pi 6th is going to be between 2/3 and pi. So this is going to be 5 pi thirds. Goodness. Yikes, I don't know how many times that bell is going to ring. And then the last one is at 4 pi thirds. So again, 1, 2, 3, 4 pi thirds is going to be right here. So 7 pi 12ths and 13 pi 12ths are kind of like halfway in between those 2 points. So here and here. And so one period of the sine curve looks like that. So that's kind of a quick rundown of what the different transformations are going to do and how you're going to determine them. Remember to go in alphabetical order. Start by finding A, figure out B, use that to get the period, figure out C, and then it's C over B to be able to get the phase shift. And then the quarter period is what you use to count by in order to get your 5 key points.